What's up, guys? Welcome back to the channel. In this video, we're going to learn how to turn every URL that you save, like in Pocket and stuff like that, into some audio that you can listen to on the go. So I'm going to be using VS Code as always. We're going to install some packages, and essentially what we're going to build is this. I use Pocket a lot, which is this quick capture tool that you can use to quickly capture links and URLs for things like YouTube, web pages, blogs, etc. And usually what I like to do is I used to like Pocket a lot because Pocket has the listen feature where you can turn all the, let's say, blog pages and articles that you want to read into some audio that you can listen to on the go. This is a common to there's a lot of variations of this kind of tool out there. And what I realized is that I wanted to build my own so that I could have, let's say, a combination of YouTube videos, web pages, blogs, everything into one place where I can just put on my earbuds and listen to, let's say, these little chunks of content, these little chunks, summaries of content, let's say, for different things. So that's what we're going to try to do today. And let's get started. Okay, so to get started, I already have obviously the project kind of set up. So I'm going to walk you through how to do that. And obviously, I'm going to make this notebook available so that you guys can check it out at some time and whenever you want. So for this project, we're going to be installing a few packages that I have here. So we're going to be installing NetSort to sort some files into the right order. We're going to be installing PyTorch, transformers, data sets from Hugging Face, PyTube, MoviePy to do some video, uh, some some video editing right within Python. PyDub, Beautiful Soup for scraping the text, OpenAI because we're going to be using ChatGPT as well to help us summarize some of the content in the chunks that we're going to create. And we're going to be using Wave to work with WAV files, which is a format for audio files, as well as a sentence piece, which actually is just a package that comes to help with transformers, Hugging Face, Torch, for honestly, I don't remember for what this thing is for, but definitely it is important. We're also going to use OpenAI Whisper, so we can do I want to be able to do speech to text and text to speech. So Whisper is pretty good at speech to text, so that's what we're going to use it for, and you'll see it in a second what I'm talking about. And I'm also going to use SoundFile to do some audio manipulation right within Python, okay? So I'm gonna get rid of this because this is not needed, and okay. So these are my imports, and notice that on the top, I have a very important import, which is a speech T5 for text-to-speech class modules. These modules are gonna be the ones that we're gonna use to do the speech-to-text, the text-to-speech. So essentially, I found this, which I really like from Microsoft in Hugging Face, which is called Speech T5 TTS, which I didn't know about, but apparently it's quite famous. And it's pretty neat, and it worked pretty well. So that's the tool we're going to be using. You can check out Speech T5 TTS on Hugging Face, and you can probably obviously explore other text-to-speech approaches that you can use or models in Hugging Face that you can use. These are just the ones that I used, okay? So I'm going to run this, all right? And so I'm going to have a processor, a model, and a vocoder, and I'm going to have this loaded, although we're not going to use it right now. First, we're going to write a bunch of helper functions that are going to help us do kind of like the pipeline of what this thing's going to look like. Actually, it's probably a good idea to give you guys a sense for what this pipeline will look like. So let's talk about that in just a second. Okay, so now that we have that loaded, let's talk about some of these helper functions. The first helper function we're going to have is a helper function to concatenate WAV files. Now, why do we need to concatenate WAV files? So if we have some big web page or some big article that we want to turn into an audio, we're going to run into problems related to things like the context length if you're using OpenAI, or the size of the amount of text that you want to turn to speech is going to give you some trouble. So what I decided to do is I decided to take this chunking approach where I can just turn small text files into small audio files and then concatenate these small audio files into one big WAV file that is the final output, okay? So that's what this function is going to be doing, all right? So to get a sense for what that means, let me see if I have it here. Okay, so in this example, and this is the example that I'm going to walk you guys through, I have these two-way files that I generated using this tool, and we're going to use them as our examples for how this tool works, okay? So I'm going to uncomment this, all right? And this is what we're going to do. I'm going to use glob to get all the WAV files inside the current folder. So I'm going to delete this, and it's just going to be speech, etc. I'm going to run this so that you guys take a look at the output. Okay, so WAV files, boom. So now I have my two WAV files here inside the current folder. Now, in this cell, I'm going to define the output file name, which I'm going to call full article. You can call it whatever you want. And then I'm going to use this little helper function I wrote to concatenate the WAV files in the current folder into this full article WAV file. So let's run this. Beautiful. So now I'm going to use IPython's audio module to listen to that output file right here in the notebook. So I can run this.
Dev is a tool that allows you to write text.
So what I get in response is the concatenated WAV file containing those two audio files. Okay. So probably not that ideal first helper function that I should write for this type of project, but I've done this project and I kind of like did a review of this project today. So what I want to do is just walk you guys through all of the elements of the project in just one notebook where you can do everything. And then you're free to like pick up the stuff that's here and then turn it into a package that you want to use for yourself. I actually have a few ideas on how to turn this into a package that I can use. Okay, so the second helper function we're going to have is this classify URL content. Now, I know many of you are probably looking at this and thinking, Lucas, why are you not using something like ChatGPT to classify the URLs? And my point on this is like, I don't think it was necessary to use like a large language model just to do classification of URLs because it's relatively simple. Like the sources of content usually for me are papers, right? Scientific articles, YouTube videos, sometimes a TikTok, and then web articles and blogs and stuff like that. So I have here a list of URLs, as you guys can see, and it contains a TikTok, it contains a couple of blog posts, and then it contains a couple of YouTube videos. So now if I run this function, here, I'm going to look through this list of URLs, and then I'm going to print the URL and its corresponding classification. So I can run this. And as you guys can see, you have YouTube, web article, TikTok, and then web article. Perfect. Now, this is this classify URL content, all right? Okay, now what we have here is a bunch of helper functions to do transcriptions of audio files. I'm not sure I'm going to use all of the functions that are here, but they're very useful and they're very interesting to know about, okay? So one is to transcribe a file, which is relatively simple. I'm supposed to be using the Whisper model to do the transcription. The one thing here is that this Whisper model should be given. And this is actually one that I'm not going to use for this project, so I would not be annoying you guys with this one. This one is for downloading a YouTube video. Essentially, what I'm doing here is just I define some path for a YouTube video, some output path. In this case, it's called YouTube video.mp4 because I'm very creative. And then I use the PyTube package to do the downloading, okay? And then I return that file path, which should have the output YouTube video saved locally on the current folder. Okay. And then I have one function to convert the YouTube video to an audio. Okay. And this one is just to transcribe the YouTube video, although it's not going to be relevant for this project. And then we have a few ones to do storing of the segments from some text file, which is essentially is just taking in a dictionary and then accessing the text inside that dictionary and looping through all of the segments inside that segments dictionary. Okay, that's just a helper function that we're not going to look at right now. And besides those two, we have one function to calculate the memory size for an audio file. It's called calculate memory size MB. And another one to split a large audio file into small segments. Okay, and that's going to be useful, and you'll see why in just a second. Okay, so now here I have the function that extracts the audio from the YouTube video. Because remember, our goal is to turn everything to audio, right? Including video or web pages, etc. Okay, so this function is for Linux because it uses the YTDLP CLI2, which apparently I discovered today is not available on Mac OS, and my machine now is a Mac. So I kind of rewrote it to use the YouTube DL, which you can install in Mac using root install on Mac OS using brew install YouTube DL. Okay, so here I'm just saying, look, I want this MP3 audio format, and then I give the URL for this tool, and I'm using a subprocess package from Python so that I can use run this CLI tool right from Python code. Okay, so in this example here, I have a YouTube video, and then I call this function on this URL and save it into an output MP3 file called output.mp3. Okay, so if I run this, so now we're downloading the video, and then we get the audio file that we can listen to real quick.
What is going on? The package just installed.
In this case, it was just a YouTube video from, I think, the Neural 9 YouTube channel, which is pretty cool. You should check it out. And that's it. Super simple, super fast, chill, right? So we have now a way to extract the audio from a YouTube video, right? And we have almost everything we need to extract audio from text. Now, all we got to do is we're going to write a function that's called extract text from web page, which is going to be extracting the text from a web page using Beautiful Soup, which is a Python package to do web scraping. Okay. So essentially what I'm doing here is I will give this function an URL, and then that function will scrape the content using the HTML, scrape the content, use HTML.parser to get the text from that content, and then return that. So if I test it on some sample URL, which is what I'm doing here, you guys can see the output. So I run it, it extracts the text from the web page, and then it will print to the Jupyter Notebook cell. There you go. So if I just call here on the text editor, you guys can see that I have the contents of that web page saved to this variable that I call text. Okay? And we're going to use this so that we can extract the relevant text from a web page. And then what we're going to do is we're going to use ChatGPT. So I have a get response function here, which is interacting with the ChatGPT API, which it's a regular response function for the API where I can just give it whatever prompt, and it will call the ChatGPT API and give me a response. So I can say, tell me a joke about using AI for automating learning and research. That's not going to be very funny. And I'm just testing so you guys can see. And then it said, why don't AI researchers ever play hide and seek with their machine learning models? Because they always know where their models are. They're either overfitting or underfitting, but they're never hiding just right. Now, I have this function set up. Let's just refresh on what we're doing, okay? So we have, for extracting audio from a web page, we have this extract text from web page function, okay? And that will extract the text from the web page using Beautiful Soup. And now we just set up a ChatGPT, an interaction with ChatGPT API, which with a simple function. And now we need a couple of functions, okay? One is going to be called extract chunks, and the other is going to be called extract chunks from URL. Now, extract chunks extracts the chunks of information from the textual response from a model, and then extract chunks from URL is a slightly more interesting, let's say, approach where I'm actually using the ChatGPT API with function calling. Okay, so the OpenAI API with function calling, so that I can use the extract chunks function as a tool to give to ChatGPT so that it can use this function here that we have here to extract content in a way that's useful for me. In this case, is to turn it into a list of chunks of text information. Okay. So if you guys are confused, it's going to be super clear in just a second. Okay. The other helper function that actually I haven't written as a helper function before, but now I will. Let me just put this token package here where it belongs. Beautiful. Okay. So now that I have this, I can go back there. Yeah, and I'm gonna use actually this to write a little function called get number of tokens. It's gonna be called def, get number of tokens. And then I'm gonna give the model name, which is in this case, should be GPT 3.5 Turbo. Perfect. And now I'm gonna call the tick token package. And if you guys don't know, the tick token package, what it does is it counts the number of tokens in your text input to whatever model you want, taking into account what model you're inputting to, right? You're prompting, so that it knows how many tokens in that prompt. So it calculates the number of tokens in the text, and it uses the information of the model to know the proper tokenization strategy. Okay. So here I'm saying I want the encoder from the model name. Okay. And then I want to return the length of the result of encoding that text. Because when we encode this text, we get a list with a bunch of token IDs. And the length of that list is the number of tokens in your prompt. So to give you guys a sense of what that means, let me just write the function here. Gets the number of tokens inside a piece of text. Beautiful. And now I can show you guys an example. So get number of tokens, write me a joke. Well, write me a joke has 4 tokens, okay? And so on and so forth. So you guys get the point. Okay, so now what we're gonna do is this. I have a list of URLs, right? Which if you don't remember, I defined it way back here, and I should not have done. I'm gonna redefine it back there so that you guys don't forget about it. Okay, so one sec, beautiful, there you go. URL is equal to this. And in this list of URLs, we have a bunch of URLs that do a bunch of things, right? So we have a YouTube URL, we have a couple of blog posts, one TikTok, and some other blog posts, which actually is going to give me some trouble, but it's okay. So what I'm going to do is I'm going to loop through these URLs, okay? And then if the URL is a YouTube page, if it's a YouTube video, I'm going to extract if it's not a YouTube video, sorry, if it's not a YouTube video, I'm gonna use that extract text from webpage function. If you don't remember, I have it right here, which takes in a URL and returns the text output from that URL. Okay, so that's what I'm doing here, if you guys can see. So I'm getting the text webpage, and then sometimes this function might return none if there's some issue with scraping that particular page. Okay, so if that happens, if that doesn't happen, what I'm going to do is, and now that I changed it, I'm going to come here and I'm going to use it properly. So I'm going to say get number of tokens, web page text, which is the function that we just defined. So I'm asking if the number of tokens is bigger than 8,192, which I know that the number of tokens in ChatGPT is 4,096. Why do I think this is 8K? I think that the new version now is 8,192. I can check that information real quick. Okay, so why did I write 8,192? I have no idea. Honestly, I don't remember. So I'm gonna leave it as 4,096 and then 17,000. This is going to be I usually consider one token to be like a 1-to-4 ratio. So I'm going to put it as 16,400. As what am I doing here? I'm saying, okay, so if the number of tokens in that page is bigger than the context length of ChatGPT, the number of tokens in the web page is bigger than 4,096, we're gonna reduce the size of that text. And here I'm using a very toy approach, very simple approach where I'm not chunking, I'm not doing anything like very fancy. I'm just like extracting all the text that I can from that web page all the way up to 16,400 length. Okay. And that's pretty much what I'm doing. Now, when I get the web page text, this is where some magic is going to happen, okay? And I could have used LangChain for this one, but honestly, I was already using so many packages that I was like, okay, let me just try to do this the simplest way possible, okay? So what I'm doing here is I'm creating a prompt to the ChatGPT API where I'm saying, look, given the following text, write 1 or 2 titles for it, okay? Then consider that for two words, it should be in the format first, second, return only the title, okay? So what am I doing is I'm creating a title for the file that I'm gonna save, and I want that title to be relevant and meaningful, and I'm extracting that title directly from ChatGPT, okay? So I extract the title here, and then I create a second prompt that says, okay, so given the following text, write a simple summary containing all the important information as bullet points, okay, from this web page. And then I get the response right here. And I get this response, which is essentially a list of bullet point information from that web page. And I feed that to ChatGPT again to extract chunks of information from the content. And the content is now those bullet points of information. Now, why did I do that? There are probably many, many ways to do this kind of content extraction from a web page text. And I did this one, I tried a few ones, and this one was the one that worked the best, this combination of these three prompts. So but it wasn't exactly scientific. So you should guys should definitely play around with this if you wanna do something similar, and not just trust that this combination of three prompts is gonna be the best thing possible. And if I wanted to do something a bit more like, official, I probably would have used something like LangChain, or I don't know, guidance framework, something to like get more structure outputs and get a little bit more structure in my prompt engineering part of this project. But this worked for me, so this was fine. And then I'm using here extract chunks from URL, okay, which is the function that, as you guys learned, extract chunks from URL is the function where I'm querying the ChatGPT API with function calling so that it can do the chunk extraction. Okay. So I do that, and then I do a check that the output is a list. So that's what I'm doing right here. And then I check also that the length of that final output is not zero, because it could have had some problem extracting the text from that output, whatever it was. So I do this check, and then finally I save the URL to a dictionary. So the URL is going to be the key, and the output and the value of that key is going to be the title that we obtain using the ChatGPT API, and the final output, which is the chunks output, with all the chunks of information inside that content. And why did I do that? Because I want content processed in a way that's easy to consume. And then I just give the dictionary and I just print it to terminal. So if I run this, I'm gonna run it for you guys real quick so that you guys can take a look. Essentially here, it's important to note, I'm just extracting the text from the web page because I'm testing just the text part extraction, because we already saw that we can easily turn YouTube videos into audio with the function that we wrote just now. So that's what I'm doing here. So it's going to take a while because it's going to, analyze a few URLs. So I'm going to cut to when this thing actually finishes. Okay, perfect. So now, if you guys can see, I got a perfect output. I had one trouble doing the text extraction for one of the URLs, but as you guys can see here, we have a dictionary with all the stuff that we wanted. We have the links properly organized, we have a proper title, and we have chunks of information properly organized inside this dictionary. So this is awesome. And why is it awesome? Because now, and this is kind of like the most magical part of this project, we're gonna look through the keys in this URL's content dictionary, which is this guy right here, which in this case has just two links and then the contents for that link. So all the information properly organized into like these little bite-sized chunks. And we're gonna use this model, okay, to do speech, to do text to speech, generate speech files, generate audio files that are actually just audio versions of this content, and save them to their respective WAV files. Okay, so I'm gonna come here on the terminal. I'm gonna show you guys. As you guys can see, there are WAV files here, and I'm gonna remove them. I'm gonna remove the WAV files, perfect, so that we can test this function live and see whether or not it works, okay? So now I'm running the function, and what is happening in this function? Well, we're running and getting the URLs, right, from the URLs content dictionary. Then I'm extracting the title from that dictionary. And then for each of the chunks inside that particular value, right? So I'm accessing that particular value using the URL as the key. What I'm saying is I'm processing the content, turning it to audio using these lines where essentially I'm using the embeddings data set from Mathis, CMU, Artex Vector, and then I'm taking that and I'm turning that into a torch tensor here, and then generating the speech with the generate speech function, which if you guys don't remember, let's take the generate speech function belongs to the model that we loaded in the beginning. So if you guys don't remember, in the beginning, we loaded the speech T5 for text to speech from the pre-trained Microsoft Speech 5 DTS. And this is just the proper, pre-processing for that file. Okay, so we're generating the speech. And remember, we're generating the speech for each of these chunks because these models can't do speech generation for like super large audio files. I mean, I don't know models that do well, that do that kind of stuff well for super large files. So we're doing for small files, then we're concatenating that into, we're turning that into a bunch of WAV files that we concatenate to have just one big WAV file. That's why we had that concatenate wave functions in the beginning. So this is cool because it allows you to like use open source in like a super cool way. This is a tool you can use for yourself and not have to pay any provider to do the text to speech, right? And you have something that you can use to do whatever. So I particularly really like this approach. And yeah, and then we save using the sound file package, and we set sample rate at 16,000, and that's it. We convert the speech variable to NumPy because the sound file package does not accept torch tensors. So you have to understand that this output is a torch tensor. So we convert it to NumPy and then we save it to file. So again, I'm gonna jump to the part where everything was saved. Just the last point, the WAV files here, what we're doing is we're organizing all the WAV files inside the current folder using the net sorted module from the net sort package, which is like an easy way to just organize everything into order. And then I set one output file that's gonna have all that concatenation of WAV files. I concatenate everything, and then I remove the remaining WAV files that we use to concatenate because we don't want to have a bunch of data in our computer that we don't need. All right, perfect. So it took a while, right? Because we're using some big models to do the text to speech, but finally we've done everything and we created our WAV file. So let's take a look at what we have. So as you guys can see here, I ran this ls inside the Jupyter Notebook itself, and we created a notebook programming.wav file and the programming environment WAV file. So we have the WAV files here. We can listen to them if we want. We can just say, there we go. So we have one.
The article discusses NemDev and GitHub.
Working perfect. And that's pretty much it, guys. So this is how you can turn, pretty much, all the content you have, like YouTube videos and web pages and blog posts, into a bunch of WAV files. And then, my idea for a follow-up project on this is to create like my own app where I do my own quick capture, my own text-to-speech tool, and everything that I consume online goes through that. So instead of having to, manage those links, and I just have a very simple interface that I can use to just, okay, so this is interesting, I save it somewhere. This is not interesting, I don't do anything with it. And which is the, let's say, overall long-term goal for this thing. And I want to do an update on this with this follow-up in the future. So stay tuned for that. And that's it. Thanks for watching, guys. Don't forget to like and subscribe, and see you next time. Cheers.